Today we are fixing Ender 3 Pro, which mainboard motherboard was destroyed. It had explosion after changing thermistor and heater and some other things. It looks like metal particle came in contact with extruder driver, NEMA driver, and exploded. Now I have this board from other repair or upgrade of the printer. So I'm going to install this newer board in this Ender 3 Pro. Now I'm looking for screws, I am packing unnecessary stuff, and I will firstly clean both the board and mounting place for the board, because there was already one explosion. I don't want to destroy another board to be destroyed. Now this fits perfectly, and it looks nice also. I am cleaning cables, especially extruder cable, which was a little bit smoked from the driver's burnout. Now, as you can see here, I messed X and Z stepper motors, and later on when I test the printer, when I try to move Z axis, it will move X axis and so on. That had me puzzled for a couple of minutes, because I didn't know if I should edit Marlin code or something else, but I figured it out. Now, the best safekeeping measure is to test the thermistor before plugging it in. The values should be 100 kilo ohms if it is 21 degrees outside or in heat block, but if heat block is heated beforehand, then it can go down to 60 kilo ohms and so on. The most important part is that the thermistor does not have continuity between the leads, which means that it is shorted. If we short thermistor pins, they go directly to the chip and it will destroy the main chip of the board. It happened to me a couple of times, so I am now very careful with these steps. Every other step, like heaters, can be tolerated. Even though there is lots of energy, but this logical part of the board is troublesome. Now I'm removing isolation from cables, because the original board was really stinky from all the magic smoke that came out of the chip, so I had to put it in Ziploc bag and remove it from the site. And I had to cut the cable. Now I'm doing some cable management. I'm looking where should things go. Everything is mounted, and I'm now going to test the 3D printer to see if the board is working. This board was a surplus from another board, from another upgrade, and the person that bought the printer got this board in the box that said not working. But as I tested it and for a couple of times, it works fine. Heats, cools, everything works fine. Board is not overheating, so I think that only maybe he had some problems with cable or something else, and he thought the board is not working, and he changed it now. The problem now with this movement of the axis is that I put wrong stepper motors to the wrong drivers. So X stepper motor went to Z driver, and Z stepper motor went to X driver on the board, and now I cannot home the printer correctly. So I decided to restart the printer and just to see if heating works. The person that brought this printer to me had a problem when he decided to heat the printer to 200 Celsius. So I put both I turned on both heating elements for hot end and for hotbed to see if the MOSFETs are working fine. Okay, so now I am doing some cable management, and I am packing everything back together. And now I have noticed that I have misplaced the cables for X and Z stepper motors. And now everything works fine. It homes perfectly. Next problem is heating element, heat block, and so on. Now when I turned on the printer, it was and I noticed that one of fans was not working properly. It created too much noise and vibration. So I decided to clean these fans to see which one is broken, and as we can see, this one is broken, the main one that is cooling the cold side of the heat block of a hot end assembly. Now half of its wings were missing. Next one was the side cooler or fan, and it was really dirty. So in this case, you will see that when I try to clean it with brush and wet paper, but wet wipes, but this fan is easy to disassemble, so later on I actually disassembled it just by pulling off the front cover. Now, with that out of the way, I'm going to put everything back together, and I'm going to look through my spare parts storage and find the suiting 24 volt up to 0.1 amp fan that has same dimensions as the broken one. Now we can use 12 volt fan, but we will need the buck down or step down converter from 24 volts that Ender 3 is using to 12 volts. Now we have two types of screws here, shorter and longer, and now I am putting them in the right place. We don't want these screws to stick more than they need to stick out. Now I'm sourcing through parts bin, and I have found a similar fan. The cable is making conflict with this case, so I have removed its limitations and put ziplock more up to the shaft, zip tie more up to the shaft, so that I have now clearance to screw this fan into place, and the cable will not be moving as much. Vibration will not break the soldering points of this cables. Now I have left a little bit of meat on these cables, little bit of length, just so that when I screw everything back and I solder these wires to the main wires that go to the board, I can have some leverage, some more length of the wires to work with. Then we can pull those wires on the board side, and it will be tightened. Now comes the soldering part. I'm removing isolation from the wires. Black goes to black and red goes to red wire. Positive, negative, red is positive, black is negative, and so on. Now I'm using Weller soldering station, and I am using little higher end solder with flux inside of the core, in order to prevent contact between red and black wires. We will put heat shrink tubing and isolate it. Now with everything soldered and done on the hot end assembly side, we are going to solve other parts of the cable management. Now I have noticed that this black tube that goes over the wires of hot end assembly is not properly mounted, so I am going to fix that. Now I will need to change heat block and heat break, and I am trying to unscrew the screw that's holding thermistor, but I was not able to unscrew it. Now I can turn on printer and heat the heat block, and then remove the thermistor, screw, and heating element, heating cartridge, but I can then easily damage the printer. So what I'm going to do is I'm going to heat with external power supply heat block or heat cartridge, and then I'm going, when the plastic is has melted, I'm going to remove both thermistor and heating cartridge. Now I'm trying to unscrew these things from hot end assembly, from heat block, but they just came right off, so nothing was holding them in place. In other words, this heat block was not changed for a quite long time and is broken. So now I am removing unnecessary parts. I only need cold end of the hot end assembly, and I will use this nozzle that came with this printer. Now I am putting everything back in place. Tightening everything. We have left and right screw, but problem with that is if you over tighten one, then it will not be flat one end of the heat block will go up and other down, and it will not be flat or leveled. So we need to tighten them little by little. Now I have installed heat cartridge and thermistor into the printer. The most important part. Whenever you are messing with thermistor later on, before turning on the printer, you need to check resistance of thermistor, because these glass thermistors can break easily and make contact with heat block, and you really don't want that to happen. Now I have this tool which will allow me to tighten the nozzle up to 1.5 Newton meters, and I need to remove nozzle from the old hot end assembly. It is mounted quite good in there, so I'm going to need to use the small wrench in order to untighten it. Now in order to use this tool, it needs to be in parallel to the thing that we are tightening. So I will raise the Z-axis to the maximum and then heat the heat plug manually again and tighten this nozzle. In this case, it's important that heat block has enough meat left for the nozzle to tighten and for heat break also. So we don't want one or other part to be more into the heat block than necessary. Now I'm tightening it and it's starting to skip, so it's at 1.5 Newton meters. So I'm checking if the temperature is reached, because we need to tighten it at a little bit of higher temperature than we are going to use for printing. Now I'm putting everything back to place as it should be, and then I'm going to focus on cable management and connecting things correctly to the board, and of course testing the thermistor before turning the printer back on. Now I'm checking this fan. The connector is wobbly, a little bit wobbly. It is not fixed in place. It's holding in place, but it goes too much up and down, so I thought that maybe that will be the problem, and I was trying to make it fixated, but later on I decided to just put it into place and see if the board will work, if the fan will work when put under the stress. Since this heat plug was heated, the thermistor value is at 70 kilo ohms. It's fine enough. Now I have noticed that hotbed is too wobbly. The wheels are not tightened correctly, so I am going to tighten them. Now this is try and error scenario case. By moving the hand I will see if I have tightened both of the wheels good. If you over tighten one, the other will lift from the profile and so on. Now this looks better. There is only spring action because springs are not compressed enough. Now I'm doing some cable management just to make clearance so that cables can easily go up and down. I'm double checking everything, and now I'm going to insert some filament into the printer and see how the filament is flowing through the hot end. Okay, so that's it. That's it from this video. Everything's fixed, everything's working fine, and this printer can now be used again. See you in the next video.